Hello, sixth graders. Welcome to Measures of Variation lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is, I can find the range and outliers of data sets by completing practice problems with 100% accuracy in multiple attempts. The first standard we'll be working on is create a statistical question given a context and develop a data set with a given measure of center, spread, and overall shape, and determine how additional data points impact these measures. Our second standard is summarize numerical data sets in relation to their context by finding measures of center, variability, and overall patterns. We're going to start today with a little vocabulary review. A measure of variation is a measure that describes the distribution of a data set. A simple measure of variation to find is the range. The range of a data set is the difference between the greatest value and the least value. Be sure those definitions are in your math notebook. Let's start with example 1, finding the range. The table shows the lengths of several Burmese pythons captured for a study. Find and interpret the range of their lengths. So what we're being asked to do is to find and interpret the range of their lengths. So when it asks us to interpret something, that means we need to write a sentence about what the range means. So to find the least and greatest values, we need to order the lengths from least to greatest. There is no shortcut. We have to actually put the values in order. So once we do that, that was step 1. Once we do that, we can see that the least value is 5 and the greatest value is 18.5. So we want to subtract 18.5 minus 5. That's our step 2. And that gives us a range of 13.5 feet. So our range equals 13.5 feet. So the range is always just one number. And the interpretation of the range is the sentence after it, where it says, this means that the lengths vary by no more than 13.5 feet. Here are 2 key ideas for you, and they're pretty important, so be sure that you understand these. Quartiles. The quartiles of a data set divide the data into 4 equal parts. That's why we call them quartiles. So remember that Q-U-A-R-T, that quad and quart, that means 4. Recall that the median, the second quartile, divides this data set into 2 halves. So the median is right in the middle, and then there's the upper half and the lower half of the data. And the median of the lower half is the first quartile, that's Q1, and the median of the upper half is the third quartile, that's Q3. So it looks like you only have 3 pieces, but you really don't. If you look at it like so, you have the median in the middle, and you have the third quartile in the upper half and the first quartile in the lower half. So you can see that that divides the data into 4 equal parts, like so. So be sure this makes it into your math notebook in the key idea. And there are 2 pages for key ideas for this one slide. Your interquartile range is the difference between the third quartile and the first quartile. So you just take the Q3 and you subtract the Q1. The IQR represents the range of the middle half of the data and is another measure of variation. So it tells how spread out that middle part of the data is. So we're going to take a look at example 2, which is finding the interquartile range. And it says the dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So it shows you all of their speeds on this little plot, and it says order the speeds from slowest to fastest. So you need to do that to find your median. So step 1 is you're finding the median, which splits your data in half. So it gives you a lower half and an upper half. The median itself does not go into either one of those halves. It stays separate. And then you find the median of the lower half. So the middle value of the lower half, there's 2 values, so you do it just like you find the median of the whole data set. You take 230 plus 240 and you divide that by 2. So that's step 2. And you find the median of the upper half, which is, again, 2 values, 250 plus 260, and you divide it by 2. So your Q1 is 235, and your Q2 is 255. So you're just finding 3 medians. The median for the whole data set, the median for the lower half, and the median for the upper half. And then to find the IQR, which is the interquartile range, you subtract the Q3 minus the Q1. So you take 255 minus 235, which equals 20. So that's your third step. So the interquartile range equals 20. And this means that the middle half of the speeds vary by no more than 20 miles per hour. So that's your interpretation of the IQR. And our final example shows us how we can use the interquartile range to check for outliers. So sometimes we can just look at a set of data and we just can tell that something's an outlier. Sometimes it's really close and it's hard to tell. So we have to check. And so if we use our data from example 2, we had a Q1 of 235 and we had a Q3 of 255. So in order to use our interquartile range to check for outliers, we add 1.5 to our Q3, and we subtract 1.5 from our Q1. So here's our steps. We're finding our outlier boundaries. So step 1 is we substitute in our values. And step 2 is we simplify so we can see what those boundaries are. So our boundaries are 205 to 285. So everything between 205 and 285 is within the boundaries and is not an outlier. And there are no speeds less than 205 or greater than 285. So our data set has no outliers. Remember, to complete your lesson, you need to finish your notes in your ISN, complete your Google form questions, review the lesson if you need to, and complete your Big Ideas math assignment in your Math Spiral notebook. Submit that when it is 100% correct and not before. Be sure to track your progress on your playlist.